like to walk through one last example just to demonstrate that the Elif part of an if, Elif, else statement truly is expandable to encompass whatever needs you might have. If we upgrade our previous example from rock, paper, scissors to rock, paper, scissors, lizard, Spock, which has a much more intricate flowchart, now there are 5 options, and so there are 5 different branches we could take depending on what our choice is. We just have to modify our code slightly in order to account for the number of branches. And the way that we implement this in code is by adding multiple Elif statements. So we always have one if to start off our branching. In this situation, we then have 3 Elif statements. We use our if for rock, our 3 Elifs for paper, scissors, lizard, and then as we did in the rock, paper, scissors example, if we have not found our choice in either rock, paper, scissors, or lizard, the fact that there were only 5 choices implies that our else statement, even though we don't check for it explicitly, is going to be assumed to be the Spock case of our branch. Much quicker this time, I'd like to go through the flow of control of this program. As we did with the rock, paper, scissors example, our program moves sequentially until it gets to our first check, and we always perform the first if check. First checking if our choice is rock. If that is true, we'll execute the block of code that corresponds with it, and then each of these 3 Elifs and the else statement are entirely skipped, and as soon as a block of code is executed, we jump down to the print statement. If our choice was not rock, then we skip the block of code that is associated with the if, and we proceed to the first sequential Elif statement and run this next check. And we continue in that way. If ever you reach one of these interior blocks of code, as soon as that block of code is executed, you jump to the end of these statements and begin again with the first line of code that comes after the final block. But if this statement is false, you skip the block of code that is associated with it and jump to the next branching question. Now, one of the things that we should have seen in the code is that there are actually 2 different types of equal signs in the Python programming language. And this is because there are actually 2 different types of equal signs in mathematics. Sometimes mathematicians make assertions with their equal signs. Let x be equal to 5. In that sense, x is being used as an abbreviation for a particular value. At other times, mathematicians will say things like, solve for x, ax squared plus bx plus c is equal to 0. And that's a different kind of equal sign. We are then finding a value of x that works, or checking what x values would make that statement true. Those 2 different types of equals that we use in mathematics, we as people are able to tell apart by context. However, a computer cannot read subtleties in that way, and as such, a computer needs 2 different symbols for telling apart these 2 different uses of the equal sign. So what you'll need to be aware of is that in Python code, a single equal sign takes on the form of that let x equal 5 example from mathematics, where it is better, instead of saying equal out loud, to instead say is assigned the value of. So remember that when we declared a variable like choice and set it equal to Spock, a better way to read that out loud is to say the variable choice is assigned the value of, and in this case we've written Spock. When we are checking to see if the value of a variable is equal to something specific, we will use 2 equal signs there in order to tell the computer that we are not declaring a variable choice and assigning it the value of rock. We are instead asking if the value of the variable is equal to rock. This is a declaration. This is a question. You should note that if you make the mistake of only putting a single equal sign in a line of code where you mean to be performing a check, it will have the effect of changing the value within the variable, which is generally not what you want to do, and that will not be a syntax error, but instead a semantic error. It's a common one that is difficult to find when you're debugging a program, but hopefully not if you learn to look out for it.